Future marine industries, a new hope for humanity. The world has already set sail for a new era of fierce competition to preempt the future marine industries. As underwater work is usually carried out in extreme conditions, the role of underwater robots is critical. Taking a powerful step to become a leader in the global underwater robot market, the Underwater Robotics Test and Evaluation Center has been built. UTech in Pohang, Gyeongsang-buk-do Province is located adjacent to the sea, making it a perfect place for the underwater robot performance tests. Built on a site of 9,910 square meters, the four-story evaluation center with the first basement consists of two buildings, water tank building and research building. The center is equipped with a three-dimensional water tank of 35 meters in length, 20 meters in width, and 9.6 meters in depth. A circulating water channel of 20 meters in length, 5 meters in width, and 6.2 meters in depth, cutting-edge equipment, and other combined facilities used for various research activities. In the three-dimensional water tank, with a water depth of 9 meters, a range of tests such as waterproof test, underwater control test, and underwater mobility test, underwater navigation test can be conducted to verify performance of underwater robots used for marine structures. The hoist covering the whole water tank building is used for launch and recovery and moving of robots and equipment weighing up to 30 tons. Various sensors and experimental equipment can be installed on the working carriage system of the three-dimensional water tank, allowing the experimenter to obtain high-quality data. The underwater positioning system is used to monitor three-dimensional underwater positions of robots and moving objects, and the indoor position tracking system is utilized when tracking positions above the water surface. These two systems are capable of verifying the position tracking and underwater navigation skills of underwater and surface robots. A total of 55 anchor bolts are installed on the walls and floor of the water tank to allow installation of various structures and connection to the robot's safety devices. Through 5 high-sensitive Full HD underwater cameras and 6 180-watt lights used for monitoring the status and performance of underwater robots and equipment, it is possible to observe the underwater experiments in progress in a more effective manner. The observation window installed in the first basement level allows you to visually observe the underwater conditions in the three-dimensional water tank at a depth of 4 meters, maximizing the efficiency of the experiment. The circulating water channel, with a water depth of 5 meters and a maximum flow rate of 3.4 knots, offers the conditions similar to the actual marine environment. Speed uniformity of 95% or more. The circulating water channel, which is the largest in Korea, verifies if underwater robots and structures work properly in the marine field with strong tidal currents. Diverse tests related to overall marine industries such as tidal current power generation industry and offshore plant industry will be conducted in this CWC. Like the three-dimensional water tank, CWC is equipped with a hoist, a working carriage system, anchor bolts, 4 180-watt lights and cameras. Particle image velocimetry, which enables a comprehensive flow visualization including the flow field, pressure distribution characteristics, and vortex intensity, is built for the tidal current generation test. PIV will greatly enhance the competitiveness of this evaluation center because it can be effectively used in the research on various marine structures, including underwater robots and tidal current power generating structures. From the control room on the second floor, it is possible to view both three-dimensional water tank and circulating water channel. An integrated monitoring can be implemented here based on information collected from a range of sensors and images from underwater cameras. In addition to this, the center has a spacious area for assembly and disassembly of heavy equipment. It is equipped with various support facilities, such as wet lab and dry lab, designed independently, as well as amenities such as shower and locker rooms, meeting rooms, and a tenant company office. Convenient metropolitan transportation network adjacent to KTX and expressways. Geographical characteristics that allow easy link between indoor experiments and marine experiments. Professional staff specialized in the water tank operation. UTech, with the best facilities and infrastructure, will promote the center as a perfect place for underwater robot performance tests by domestic and overseas research labs. This center can also be used for other purposes such as movies, games, and military equipment tests. Gyeongsang-buk-do Province and Pohang City each invested 8.5 billion Korean won into the Underwater Robotics Test and Evaluation Center. As a mecca for development of underwater robots and equipment, including underwater construction robots, it will serve as the outpost of the future marine industries and lead the regional economic growth by creating various added values.